About Ian Cooper, principal engineer in London, speaker, tabletop gamer, geek, tattooed, pierced, and fierce, and bearded. The Gov on Brighter. The Gov on Brighter. I'm sure you're going to tell a little bit about that. So let's welcome Ian to the stage with a big round of applause. The stage is all yours.
Everyone hear me? Okay, that good? Yeah, we go. All right. Has anyone seen my talk, TDD Where Did It All Go Wrong, online? A few of you. Okay. There's a talk, you can find it on YouTube. It's called TDD Where Did It All Go Wrong, and that's the one to share with your colleagues if you like what I'm talking about here. This one is a little more detailed. Who actually practices TDD in this room? Who's tried TDD but gave up on it? Who's never seen TDD in their life? Okay. For anyone who, I'm not going to teach test-driven development in this session. For those of you who don't know, what we're talking about is the practice of writing your test first. You write a test that fails, the red stage. You then get that test to pass by writing the code, the green stage. And then essentially, after that, you refactor the code to improve its design. All right? So that's the basics of TDD that we can all agree on. A lot of people do bounce off TDD. I will probably explain why during this session. This is just, I'm old. This is an hour-long talk I'm compressing into 40 minutes, so we'll move on from me being old. I work on an open source project for .NET developers called Brighter. We compete with things like Mediator, Mass Transit. We are useful for messaging, for CQRS. If you're a .NET developer, please check us out. Okay. So, what's our agenda? We're going to talk about some fallacies and some principles. So the fallacies at TDD I'm going to talk about are that developers write unit tests, that the trigger for a new test is a new function, that customers write acceptance tests. It doesn't matter if you test first or test last, and that you want 100% test coverage of your code. These are all lies. And I'm going to explain why. Okay. The first and the biggest lie you will hear about test-driven development is that developers write unit tests. That is not true. What is a unit test? So this is Wikipedia's definition of a unit test. To isolate issues that may arise, each test case should be tested independently. Substitutes, such as method stubs, mock objects, fakes, and test harnesses can be used to assist testing a module in isolation. That's a lot of words, isn't it? Right. So in classical approaches to QA, what would typically happen, once upon a time, is we would develop our software in modules. And we would then test that module as a black box. That is the unit, the system under test. Having tested all the modules, we then want to test that when they are basically hooked up together, it works, which was called an integration test. And which tested just the, say, two modules work together, and then you had a system test, which tested all of those modules working together. What happened a little bit in test-driven development is when test-driven development came out, some people who were not really closely looked at what the extreme programming community were describing simply took the practices of classical testing and applied them to TDD. They were not welcome and they were never wanted, but they have essentially derailed test-driven development ever since. And the problem is this idea of substitution and isolation. Because what happens is developers essentially say, okay, I am testing a class. I must isolate this class from all of its dependencies. I will replace those dependencies with test doubles, mocks, fakes, something else. And that breaks test-driven development. So at its height, this kind of strategy led to a thing which Gerard Mazaris, in his book X-Unit Test Patterns, referred to as need-driven development. It's a variation where code is written from the outside in, and all dependent upon code is replaced by mock objects that verify the expected indirect outputs of the code being written. What do we mean by that? So basically what it means is there's some implications, right? So what happens is we have to think about this. We've got two options. One is, ahead of writing any code, we need to think about the structure of the classes that we want to use to implement it. Typically, we've done some whiteboarding, some CRC cards, produced some lovely UML diagrams. We've done a lot of upfront thinking. We have to do that under this strategy because we have to understand that this class has this responsibility, not these responsibilities, which belong to another class. Alternatively, you can use a kind of exploratory process here where you begin by effectively writing tests for a class, and as you get to the implementation details, you start saying, I think that behavior belongs to a collaborator. I will inject, put an interface into my class. I will then basically effectively mock that interface, and later I will go out and actually build the real thing. And what happens is your class has a whole load of injected dependencies as a result. Okay. And that is because you are seeking this unit isolation. The second thing that happens is that your test is structured around checking the calls that you make to these dependencies. And that means that your test understands the implementation details of the code that you are testing. If you change the details, the implementation details, your tests will break. And this is the common complaint people have about test-driven development, which is, I change something and all these tests break, and I have to go and I change all my mocks in order to get it to work. And then what happens is people say, I don't want to change any of that because if I change some of that stuff, my tests will break. So I'll write another class over here rather than modify that one, it's too hard. And the thing is, what happens is these tests inject rigidity into our code. But the point of TDD was supposed to be to create suppleness for our code. In the presence of our tests, we'd be able to change it. So something went horribly wrong. In 2007, I had this to say about this on a blog post. This is how long we've been talking about this issue, right? There's a thing called Brandolini's law. Alberto Brandolini famously said it takes an order of magnitude greater effort to undo bullshit than it did to create it in the first place. So we are still struggling against this misapprehensions. When I look around now, I see a lot of people using mocks to replace all the dependencies. My concern is that they will begin to hit the fragile test issues that mocks present. Jared Mazaris identifies the issues we hit as two specific smells: over-specified software and behavior sensitivity. So essentially what happens is if you've got a strongly typed language, you're going to have to basically create an interface as your dependency. You're a little bit off in dynamic languages because you can just pass in the object. And what happens with that is meant that effectively, because we're injecting all these dependencies rather than just newing them up in the constructor, then what tends to happen is we have to deploy inversion of control frameworks because it becomes too complicated for us to do what's called poor man's DI, which is just new things up at the top level, right? So the whole growth of IOC frameworks and their explosion into our code bases is somewhat predicated on this idea that I have to inject all my dependencies rather than just newing up a class in the constructor. The problem is, if we change the implementation details, our tests break. Okay. And our tests are then focused on the implementation details and not the contract. So what should we actually be doing? Okay. So developers write something called developer tests. So in his book, TDD by Example, Ken Beck said, I call them unit tests, but they don't match the accepted definition of unit tests very well. In fact, Ken only uses the word unit test once in his book, and this is the reference. He never refers to unit tests elsewhere. And the reason he says they don't match the accepted definition is because he means they don't match the classical model of unit integration system test. They have nothing to do with that. We'll explain where the unit test confusion comes from in a bit. So Martin Fowler wrote a book on refactoring, and he said, refactoring is a change made to the internal structure of software to make it easier to understand and cheaper to modify without changing its observable behavior. Refactoring depends upon the presence of tests. The tests confirm the observable behavior. When we make a change to the internal structure, not the observable behavior, then none of our tests should break. If you use mocks everywhere, your problem will be that your tests will break. You're no longer doing safe refactoring because you're constantly rewriting the tests that were designed to prove that the implementation change you made to some kind of faster algorithm to some new class structure didn't actually affect the behavior of the system under test. So red-green refactor, you should be refactoring, all right? So typically, we'll mention this a bit later, but in the green stage, you're supposed to do anything it requires to pass the test as quickly as possible. What is the algorithm I need, right? Cut and paste from Stack Overflow, ask ChatGPT to generate the code for you. That's fine, absolutely fine, all right? Refactoring is when you make that good, when you turn it into nice design, right? But the key idea here is that the contract that our tests maintain of the publicly observable behavior of our system is not changing. So that's what effectively our tests guarantee to us still works. All right. So I can change my code details, I can refactor stuff. I can go to a long method, I can go into that method, and I can say, this looks like it should be a separate class. I can do extract method on a smaller portion of the method to pull it out. Once I've done extract method, I can look at the parameters and say I'm going to turn some of those parameters into arguments to a constructor, and then I'll only have a small number of parameters that may change per time. I call this in the actual method, and I can pull that whole class out. I do not need any new tests. That is an implementation detail of the observable behavior of the class I just extracted it from. I already have tests that cover that. Many of your classes and code do not need to be directly tested because they are implementation details. If you're in a language with access control, they are often things like private, internal, right? If you have a module system, they are things that are not exported from your module. You only need to test at the responsibility boundaries. Ken Beck said, if a program's behavior is stable from an observer's perspective, no tests should change, right? We are defining a contract, an API, if you like, that a class exposes, and provided that behavior doesn't change, we can change the implementation as much as we want, and no tests should be impacted by that when we do that. Tests should be coupled to the behavior of the code and decoupled from the structure of the code. This is Kent's kind of personal statement. My personal style is I just don't go very far down the mock path. Your taste is completely coupled to the implementation, not the interface. Of course, you can't change anything without breaking the test. He said this in an interview in response to some questions from DHH about test-driven development. Right. So, some more useful definitions. In unit testing, we say failure implicates one and one only unit, hence why we have to substitute dependencies, all right? When we're writing a programmer, sometimes called a developer test under test-driven development, failure implicates the most recent edit. So the change that you just made, because you're doing test-driven development, you write a new test, it's red, you go and make some changes to try and get it to pass green. Maybe that one passes green. You run the whole test suite. Some other tests break. The code you just wrote broke those tests. That gives you basically isolation of the code that has caused the problem. You know because you just wrote it, right? So the fuller version of this statement, I don't know whether the C2 wiki is up anymore, but the test-driven development produces developer tests. The failure of a test case implicates only the developer's most recent edit. This implies developers don't need to use mock objects to split their code into testable units. It implies a developer may always avoid debugging by reverting the last edit. Now, I'm not always quite so fierce. Some of the TDD purists are, hey, if effectively you make a change and it breaks all of the tests, you should revert the last edit and start again. I'm a bit like, you could use the debugger, it's okay, right? But the point is to avoid breaking your flow and your flow by having you get into a lengthy debugging session. One of the key ideas here is when you're writing your test, pick small increments of functionality. Then essentially it's easier to say, I'm just going to abandon that and try again. Or it's easier to say, hey, it's only about 5 lines of code that I added. It should be pretty easy for me to reason about where it went wrong. Yeah, I think I've said most of those. Okay. You can get these slides, by the way. They're on a PDF on my GitHub, Ian Cooper. So a lot of these the call-outs are just ready to help you to read the slides afterwards. So where does unit test come from? So the thing that Kent didn't want to happen was that effectively your tests were slow, or that running one test changed the results of another. So the isolation he sought was between tests. And that's why he used the phrase unit. What he meant was no test should interfere with another, so that we can run them in parallel and then we can run them fast. Okay? And so actually, generally the reason why tests run slow is I/O. And generally the reason why they have problems with what we call shared fixture, which is, in other words, state where one test changing impacts another test, is some shared state like a database, etc. And those are candidates for mocks, right? So we mock I/O because effectively of the speed of the tests and the reliability of the tests. And we mock things like databases because of the cost of effectively one test interfering with another, all right? But that's the genuine reason to use mocks. Okay. The second fallacy I want to approach is the idea that the trigger for a new test is a new function. So you can look at Wikipedia. Wikipedia is wrong. It tells you that essentially the way you do test-driven development is you write a test that defines a function or improvements of a function. And that is another lie. You don't do that either. Okay. A function, I can understand why, right? A function has preconditions, postconditions. Your test would therefore be asserting that given these preconditions, you run the function, you get some postconditions. It would make sense that basically that is something that's testable, right? So implementation is simply saying, hey, I can get to the observation where these preconditions hit these postconditions. And that creates this belief that the function is the system under test, all right? Okay. It creates a lot of problems, though, for us. Because typically, when you have tests in this style, when you come to look at them, it's very difficult to understand what does the system need for this function? What is it doing in terms of something the user cares about? If I have a test which just passes parameters to something, it's like, well, it doesn't tell me about the system. It doesn't tell me how to use the system. And it doesn't really tell me how I could refactor this system to make it work better. Quite often I'd find a test has gone red, and you say, well, is that because I broke something, or is that because actually the behavior that I want to reference from this test has changed? I can't see the behavior, though. I can just see a test of a given function. So, you know, this promise that TDD advocates say, which is, hey, you can throw away the documentation, just read the tests, seems to be a really great lie, right? Because I look at test bases and I go, I've got no idea what anyone is getting at from this test base. And the reason that's a problem is the trigger for a new test in TDD is a new behavior. Or, if you like, a small part of a new behavior that you want to get under test. So this is, if you look at TDD, this is basically from Kent Beck's book. It's by example. He's working through an example. And he says, we need to be able to add amounts in two different currencies and convert the result given a set of exchange rates. That is what is prompting Kent in the book to write a test. Okay? Given a set of exchange rates, when we add amounts in two different currencies, then we convert the result. You can rewrite that like this. Given a set of exchange rates, when I add two amounts in different currencies together, then I get a result in the first currency. This is not something you do in SpecFlow. This is how TDD works. Okay? Given the state of the world before the test, when I exercise the behavior under test, then we expect the following changes. You can structure this by setup, given, exercise, when, verify. You can structure this by act, arrange, or assert. But that is how tests work. They are testing behaviors of your system. And that's what led Dan, who's around at the conference, to basically come up with this observation. I found the shift from thinking in test to thinking in behavior so profound that I started to refer to TDD as BDD, or behavior-driven development. Now, BDD is now something else. right? It's become a full kind of scope practice. So that's not really what we're referring to here. But the reason Dan made this statement was because he wanted people to think about behaviors, not tests. And this is really early on in the life of TDD. He could see it going wrong. So TDD is not really a technique for testing. It's I think of it as a contract-first way of exploring an API. You are saying, what is the API I need to satisfy this requirement? I'm going to explore that. I'm going to write it down, and I'm going to see it feels good. The programming to that API feels comfortable, and I understand what is going on, and it reveals intent. That is where you are doing design. You are designing the API. You do design of the code later in the refactoring step, and you can defer that for quite a while, but your key thing is, I want to make this API easy to use and easy to understand. All right. The next test you write in TDD is the most obvious step you can make towards implementing a requirement given by a use case or user story. All right. So the classic question in development, what should I do? Pick up the next test. What's the next test? It's the smallest change I can make to the system under test to express part of that acceptance criteria. So you move in tiny increments if you can, right? And we pick up use cases or user stories, so requirements. Okay. If in refactoring, which we mentioned earlier, I decide, I need to break up the answer here that ChatGPT wrote that's like all these lines of code, and I'm going to turn it into a number of classes, again, I don't need new tests. Those classes are tested if you use refactoring approaches, which mean you're not introducing conditionals or branches in logic that don't come under the original test. The original test covers those. They are implementation details. I might break out a class. I'm going to pick on Eli. Eli might say, that's rubbish. I'm going to inline that back in again. This goes back and forth for a while until we settle on a better design. And that's perfectly acceptable. That's what TDD is for. If you start wrapping tests around those private details that you expose, the design becomes rigid and inflexible. And we can't have that dialogue via code to see what happens. Okay. Those, as I said, the call-outs are mainly for you later on when you look at this stuff, right? So I flicked through a few of them in the name of speed. Customers write acceptance tests. Anyone here uses spec flow, things like that? Okay, one or two of you, just stop. All right, are those of you using spec flow, how many times has the customer sat down and written the test, the product owner, right? If the product owner is not the person using spec flow to write the tests, do not use spec flow. That is the only point of spec flow, is that the customer writes the test. So originally we called these functional tests because each acceptance test tries to basically test the functionality of a user story. Modeled and possibly even written by a customer, hence the newer name customer test, right? So the idea was this on-site customer, nowadays we think of them basically tend to be thinking as a product manager, would say, hey, here's what the code is supposed to do. And the idea was they would define the acceptance criteria for the story. And some bright spark thought, well, rather than just writing down the acceptance criteria, they could write the test using that spec flow. And I've never seen it happen. I've never seen a product manager go into a room and go, great, roll me up spec flow, I'm going to write them tests, right? And they don't even if you write them, they don't look at them, they don't care. So you go through the process of being forced to use an unnatural English language syntax language to write your tests and then convert the results into something you can run. Just write a unit test in TDD. Just write a programmer test, rather, right? Okay. So James Shaw called this out. James Shaw was one of the people that wrote Fitness, which is an earlier customer acceptance tool, and he said that customers don't participate and they create a significant maintenance burden. Acceptance testing is not worth the cost, and I no longer use or recommend it. James is around somewhere, I think, at the conference. Okay. The trouble with acceptance test-driven development is it's reinforced this belief that TDD is about the units. If the acceptance test is about the behavior, then what would the TDD be about? Well, it must be about something smaller, the units, right? And that's a problem. Really, we just wanted actually the behaviors to be expressed in our TDD practice and the program or developer tests. Okay. This one is, well, mentioned that in passing. One of the other struggles with things like spec flow is that quite often you write them at the beginning of, say, your iteration, you write the test, and then you have to spend days before you get to the point of implementation where that higher level test would pass. That means your test suites are frequently read. That means developers ignore them because they know that they're read. That means at the end of the iteration, there's a mad scramble to try and basically make them go green. They're just not worth it. Customers specify acceptance criteria is the practice you want, right? Ask the product team or the customers to tell you, how does this behavior work? What is the acceptance criteria for this behavior? So customers illustrate their descriptions with concrete examples. Programmers use these examples to guide their work. Sometimes programmers use the examples directly in their test. More often, programmers use examples as a guide, writing a multitude of more focused programmer-centric tests as they use TDD, right? So get the product owner to establish the acceptance criteria, use those to guide your exploration of behaviors through test-driven development. There is no other level of testing. Next fallacy people sometimes have, it doesn't matter if you test first or you test last. Okay. I see this quite a lot. People say, I've got tests, right? I wrote them afterwards, but it's okay because I have tests, and therefore I've achieved the same result, haven't I, right? Very typically, what they are writing is unit tests, unit integration and system tests, because they're not doing test-driven design. So they're writing an entirely different type of test, the ones TDD produces. But this is what I tend to call test after, which is a development process that entails executing unit tests after the development of the corresponding units is finished. All right. It implies that you're effectively not using a process like TDD to discover your design and using refactoring to move towards it. It implies that you have some rigid idea of design which you have effectively hard-coded in and you are now confirming the behavior of. If you write tests without knowing that they are tied to behavior, you are engaging in speculation. You are speculating that that behavior, or that functionality will be needed when you come to implement the behavior that the customer requires later. Often you will be wrong. If you've ever been through a code base and a latent bug has appeared and you realize, wow, this code path has never executed before in the last 2 years, that is because of speculative code. Someone wrote code that wasn't required by a behavior, and it suddenly emerges latent because essentially the code is suddenly called into action. Typically, speculative functionality will need rework, which is often about 40 to 50% of the cost of doing it, if it's needed at all. Right? So generally, you only want to write code that you know you're going to need. So the principle you want to do is only write production code in response to a test, where the test is expressing one of the behaviors identified basically in the requirements of a use case or user story. Okay. So you only write production code in response to a test, and you only write in the test in response to a requirement. So you can't write speculative code anymore. You're only writing code that satisfies users' needs, right? If you say, well, I don't have a clear requirement, I don't have clear acceptance criteria, TDD is not going to save you. What's going to save you is a conversation with a product owner saying, this is really unclear. What are we supposed to be doing? Right? If you don't know what you're supposed to be doing, the first thing you shouldn't be doing is writing code. You should be having a conversation. All right? And that conversation will define the acceptance criteria that you need. Okay. So, yeah. The test is effectively responding to acceptance criteria. So Kent Beck said, you need a way to think about design, and you need a way to think about scope control. Okay. The design, which is essentially when we think about the design of the surface area that we want to bring under test for the behaviors, the API, if you like, the things that we export, right, the things that essentially will be driven by our final system. And refactoring will help you change that design to keep it working. And you need a method for scope control, right? You need a way to avoid writing unnecessary code and only writing code that comes from a user requirement. And TDD will give you that. Test after will not give you that. It cannot do scope control and it cannot do design. Right. So it's a kind of design by contract model. We establish the contract and then we implement that with design, right? Okay. Having said that, you may not want 100% test coverage of your code base. Ken would say, TDD, if followed religiously, will result in 100% statement coverage because we don't write code unless it's in response to a test. So why would I say it's actually a bit of a fallacy to have 100% test coverage? Okay. A lot of even teams that practice TDD, we have a lot less than 100%, right? Quite often 60, 80%. But why has that happened? Okay. The problem is that TDD is not great for driving all forms of code. It does some things better than others. Particularly what TDD does well is it drives your domain model, the problem area. What it doesn't drive as well are things like I/O, anything where effectively I'm implementing an SDK or UIs. So TDD's purpose is to provide what we call fast binary feedback. Binary, it's either green or red. The test passes or the test fails. It's the clearest form of feedback we can get because it tells us yes or no. There's no nuance we have to interpret, all right? And it's fast because our goal is to mock away I/O and shared fixtures so they run really fast. So it doesn't break our flow. We can keep thinking about the next step, the next step, the next step to implement a requirement, and we stay in the zone, right? If TDD, if you're using a TDD approach, but you're not getting those behaviors, it's not fast and it's not binary, it's probably not a use case for TDD. So if you're doing stuff with UIs where effectively it's not just red or green that this actually works, it's kind of like, hey, I need to interpret these results and quite often they're fragile and they break, don't use TDD to do that, right? If what you're doing is not exploring a design, but just implementing something, then quite often TDD is not also the right use case. Okay. So I tend to avoid driving visual output. There are some nice tools out there, but typically they are more useful in a test after scenario, where effectively what you're saying is, having built this thing, I want to regression test it. Typically, you don't design the UI through TDD, right? What happens is somebody in the UX department designs the UI and gives it to you and says, implement that. You're implementing, you're not designing. TDD probably won't help you. Test after may help you with regression issues, right? Obviously, if you're just throwing the code away, basically, effectively, just spike, something like that, TDD doesn't really help you. Just go to the CLI and, a REPL or whatever and just test things out, all right? Integration, if you basically then have some mocks around I/O and you need to go and actually implement the class that does that, generally, it's just mechanical. I need to go in and fill in how this database statement works in this particular language. There's not much exploration going on. Typically, one of the easiest ways to do it is to essentially just go and get help off ChatGPT or Stack Overflow. You get it running, and then you can test it, right? So those kind of tests, quite often, test after is a better strategy because there's no real rapid exploration. And typically, when you're doing that I/O stuff, you're just thunking your way through stuff that takes you a little bit of time, and you lose that feedback loop anyway. Right? Don't drive third-party code. It's not yours. Right? Test that after. So you won't get 100% test coverage because not all of your code is actually the code you should be using TDD with. We don't talk about it in here. Typically, I would recommend using something like Alistair Coburn's ports and adapters architecture, where effectively you separate, hey, the stuff that lives inside my domain, which he calls confusingly the application, and the drivers or driven I/O or things that basically call my code or things that my code calls that live outside. So I/O, tests, that kind of thing, right? And it gives you a nice separation. Okay. So people talk about the testing pyramid, right? The idea behind the testing pyramid is different types of tests give you different amounts of fragility and different amounts of time to feedback. You want the plurality of your test code base to be things that give you fast feedback with low effort and fragility. The more things that you have that are fragile, effectively the longer your release cycle gets because of the pain of those fragile tests, right? So focus on TDD, but you will need some automated tests around I/O for regression. You may want to look at your monitoring alerting to look at your observability and determine whether that can give you feedback, and you may want to use manual tests. But each one of those gets harder. So you want the weight to be towards the bottom. All right. So we went at quite a lot of speed through that. I quite often take an hour to do it, so hopefully that wasn't too fast. But we'll review. All right, what are the fallacies? So the fallacies are that developers write unit tests. All right. Try and forget unit, integration, system, acceptance outside of the test after kind of context where they're useful. They're not useful in a test-driven development context. The trigger for a new test is a new function. Okay. The trigger for a new test is essentially not a new function, right? Don't worry about the detail of it being a method. All right? If I add a new method or I add a class that's an implementation detail with a method, right? Customers write acceptance tests, right? Your customers are not going to sit down with SpecFlow and write them for you. You're fooling yourself. It doesn't matter if you test first or test last. Test-driven development gives you design and scope control. If you value those things, test first. And you want 100% test coverage of your code. TDD is one part of a successful QA strategy. What are the principles? Developers write developer tests. The trigger for a new, that's number 3, that's odd, I haven't even tested this. The trigger for a new test is a new behavior. Customers write acceptance criteria. Only write production code in response to a test. And not all of your code should be driven by TDD. So developer or programmer tests are really what you're targeting, right? That is this notion of the code you added or changed in your last edit is basically what you are saying is that how you locate where failure happened. So you work in small chunks in order to effectively make sure that the amount of code you have to understand where the error could be is not great, and you could revert if necessary. Trigger for a new test is a new behavior. So generally, if you take 2 and 3 together, what you really want is a process that says there's some kind of use case or user story, whatever your preference is, created by a product team. They establish, you and they discuss the acceptance criteria. How can we prove this is working? What are the tests around this being correct? You use those to generate small little increments that you begin to work on, each one effectively uncovering more of the behavior and helping you move towards your final design. Only write production code in response to a test, right? So this idea effectively that we say the production code effectively should only exist because a test has driven it, but not all of our code should be driven by TDD, right? Balance that against the appropriateness of the TDD tool suite helping you as opposed to becoming painful. And that should be that. Thank you very much.
Ian, thank you very much for this amazing talk.